Right now we're looking at a neon bulb load on the secondary system, and it loads down the voltage quite a bit, from 5 to 15 volts total. To 4.49 volts. We can see that. In between here we've constructed the phase angle for the first segment of input. That phase angle looks like it's changed quite a bit. It's been on for a while. Well, based on an earlier measurements, we come up with 73.9 degrees, and before that I measured 60 degrees. It's probably looking right there. That's right. That's correct. That's based on using 2, 3.6, and 3.6 as our input parameters. That yields a 73.9, 74 degree phase angle. We can see that that is there pretty much in little variance. 2 and the 3.6 values are staying the same. So there's 74 degrees of the 180 to be used up. Now we're going to look on this next segment. Anything that we arrive at over 180 degrees is an excessive time created voltage, which then we could subtract that voltage from the ordinary voltage and try to deduce how much extra time has been used to power our process. Now here's our process. We now got a neon going through there. We got 16.25 milliamps of neon current coming out from a 42 to 1 step-up transformer. Pictured there with an amperage meter on the primary of that transformer. Circuit is providing 0.84 amps to the process from a 5.14 volt source. That's relatively stable also. It's nice how the neon discharges will equalize the, it takes out the up and down cyclic movement of the quantities very well in some cases, especially here. We're able to deduce these phase angles pretty easy because they're not wildly fluctuating. Okay, then back to our input conditions. Our 6.3 volts on phase 1, 5.7 on phase 2, and 5.1 on phase 3. Our amperages. We've lost 0.7 amp on phase 1, having 107 amps. Phase 2 has 0.85 amps. We've lost about 1.2 amps. and phase 3 is barely drawn upon. The open circuit condition is 1.7 amps across the line on all 3 phases. The secondaries are pictured over here. See if we can raise one of them up. That should be, that red meter sticking up should be the voltage being acquired from the system. When I raise that coil up, that amperage should have gone down. That shows us that that's where the system's hooked up. And once again, we'll show what those single double spiral loops look like. They're mega cable, Radio Shack mega cable. At condition 14 gauge according to their specs. Now we're back to the last problem here now then. We got 197. We had 74 degrees. We got a new phase angle. 1.97 squared plus 2.02 squared minus 3.92 squared. And then divide by sum 2 times 1.97 times 2.02. That gives us 0.93 minus. That gives us 158 degrees. $158 degrees, folks. So what this means then, that accounts for almost 160 degrees. The other one, we could say is another 60 degrees. Be sloppy about it. That'd be 220 degrees. We're therefore 40 degrees over our norm of 180 degrees. Or approximately 30% overclocked or overtimed in this source. So that would be 58, and we're going to use, no nonsense, these are precise figures.